Hello everyone and welcome to our YouTube video for the OS project for CSE Batch 20. We are Group 3 and we were assigned page replacement algorithms. We decided to design and develop a website in order to showcase this concept. And this is the home page of our website. The home page starts off with a navigation bar with a logo on the left hand side and three different buttons that help you navigate our website. The home button, which is the page we are currently on, the algorithms button, which we will see shortly, and the About Us section, which is basic information about the people who worked on this website. So, what are page replacement algorithms? In an operating system that uses paging for memory management, a page replacement algorithm decides which page is going to be replaced and when it is going to be replaced. Since actual memory is much smaller than virtual memory, page faults can occur, and this is where the page replacement algorithm comes into play. So you might be wondering, what is a page fault? Don't worry, we will get to that shortly, but first, some more about the website. In order to make our website more interactive and fun, we included a chat with us option, which gives more information about the algorithms we have worked on. So a user could type in LRU, which is least recently used, and they would get a link in order to research more about this topic. Let's learn some more. This is the algorithms page. On this page, the user can select which algorithm they want to run or want to know more about. For this particular project, we have worked on 4 different algorithms. They are least recently used, first in, first out, last in, first out, and optimal page replacement. Each algorithm has 2 sections. A theory section where the user can learn more about the background of the algorithm, witness an example, and even know about the disadvantages and advantages. The second section is a simulate section in which the user can enter their own custom reference string alongside the number of page frames they want and run the algorithm to see what happens. Let's start with least recently used. The first algorithm is the least recently used algorithm. In this algorithm, we keep track of the pages that are coming in and out of the frames over a period of time. The algorithm assumes that the pages that have been used most recently will continue to be used heavily in the future. So when there is a page fault and it is time to replace a page, we replace the page that has not been used for the most amount of time. Before we move on, let's understand what a page fault is and what a page hit is. A page fault occurs when the page at the top of the queue is not present in the frames. And a page hit occurs when a page at the top of the queue is already present in the frames. Let's understand that using an example. For this particular example, the page reference string is 3, 1, 2, 1, 6, 5, 1, and 3. 3, 1, and 2 enter the frames alongside 3 page faults as they did not exist before. When we go to add the 1, we notice it is already present and therefore we note it down as a hit and move to the next page. The 6 replaces the 3 as 3 has not been used for the most amount of time. Similarly, 5 replaces 1 and 1 replaces 2. The last page is 3, which replaces the 6, as out of 1, 5, and 6, 6 has not been used for the most amount of time. Moving on to the advantages and disadvantages. The advantages of LRU is that it does not suffer from Beledi's anomaly, and it is more efficient as compared to other algorithms because it has a lower number of page faults. The disadvantages, however, are it requires additional data structures to run, making it more complex and heavier on the hardware when we run it. Let's simulate it using our own custom reference string and number of page frames. This is the simulations page where the user can enter the page reference string and the number of pages frames that they would like. Let's use the string 1, 3, 0, 3, 5, 6, 3 alongside 3 page frames. When we run it, we see 1, 3, and 0 are added as page faults as they did not exist before. When we go to add a 3, we notice it is already in the frames and note that down as a hit and move to the next page, which is 5. The 5 replaces the 1 as 1 has not been used for the most amount of time, and the 6 replaces the 0 as 3 had just been used. Finally, the last page in this string is 3 and we notice that it is already available in the frames, so we note that down as a hit and move to the next one. At the bottom of the table, we have a summary of what just happened. We used 7 pages over 3 frames and had 2 hits and 5 page faults. Alongside this, we have also given the hit ratio and the miss ratio, so we can compare the algorithms later on. Moving on to the second algorithm. The second algorithm in the list is first in, first out. So let's have a look. FIFO is the simplest algorithms out of all the ones we have implemented, and it just replaces the page that entered the frames first. So let's consider that using an example. We'll use the same reference string as before so we can compare all the algorithms later on. 3, 1 and 2 enter the page frames alongside 3 page faults as they did not exist before. When we go to add 1, we see it is already present, so we note it down as a hit and move to the next page. 6 replaces 3 as 3 was first in, and 5 replaces 1 and 1 replaces 2. The last page 3 replaces 6 as out of 5, 6 and 1, 6 was first in. Let's understand the advantages and disadvantages. The advantages of FIFO is that it is simple to understand and very easy to implement. However, the disadvantages are that it has poor performance and it does suffer from Belady's anomaly. In this anomaly, as we increase the amount of frames, the amount of faults increase as well. This does not occur in other algorithms. Let's simulate this algorithm. We will use the same reference string as before, 1, 3, 0, 3, 5, 6, 3, using 3 page frames. When we run this, we see that 1, 3 and 0 are added as 3 page faults. When we add 3, we notice it is already present and note that down as a hit and move to the next one. The 5 replaces the 1, the 6 replaces the 3, and the 3 replaces the 0. And we have 3 more misses. Under the table, we have some more summarized data. We used 7 pages, had 3 frames, had 1 hit and 6 faults. Notice how the number of faults is more than LRU for the same reference string. This shows that first in, first out is less efficient. Let's move on to the next algorithm. The third algorithm we have implemented is last in, first out. So let's have a look. The last in, first out algorithm is pretty similar to FIFO, the only difference being the page that had entered the frames last is the one that is replaced. Let's see that using an example. We will use the same string. 3, 1 and 2 enter the page frames as 3 page faults, as they did not exist before. When we go to add the 1, we notice it is already present, therefore we note it down as a hit and move to the next one. The 6 replaces the 2 as 2 entered in last, and the 5 then replaces the 6 as 6 has entered in last. As we go to add 1, we notice it is already present in the frame, so we count that as a hit and move to the next one. 3 is also present in the frame, so we add that as another hit and move to the next thing. Let's move on to the advantages. The advantages of LIFO are it is very simple to understand and easy to implement. However, the disadvantages are that it does not consider the locality principle and therefore it can have bad performance. It can also occur in LIFO that the old pages just reside in the memory forever, and even if they are never used. Let's simulate this using our own input. We will use 1, 3, 0, 3, 5, 6, 3 with 3 page frames. As we can see, 1, 3 and 0 are added in as 3 page faults. When we go to add the 3, we notice it is already present, so we note that down as a hit and move to the next one. The 5 replaces the 0 as 0 entered in last. The 6 replaces the 5 as it entered in last. And 3 is already present in the frame, so we note that down as a hit. Below is the summary of all the data we just used. Moving on to the last and final algorithm. The final algorithm we have implemented is optimal page replacement. So let's have a look. Optimal page replacement is the best page algorithm that we have implemented, and it is the most efficient one. This is because it ends up in the least amount of page faults. In this algorithm, we replace the page that is not needed for the most amount of time, or the page that is not needed at all. Let's understand this with an example. The page reference string 31216513 is what we have used. 3, 1 and 2 enter the frames as 3 page faults as they did not exist before. The 1, we notice it is already present in the frames, so we count that as a page hit and move to the next one. The 6 replaces the 2 as if we look into the string, we see that 2 is not needed in the future. The 5 then replaces the 6 as if we look at the reference string, 6 is also not needed in the future. If we look at 1, we see it's already present in the frame, so we count that as a hit and move to the next one. And 3 is also present in the frame, so we count that as a hit. The advantages of optimal page replacement are that it is very efficient, it is not that complex, and it is easy to understand. The disadvantages, however, are it takes time to run, it's hard to manage errors in this sort of algorithm, And the main disadvantage is that we need to be aware of the pages that will come in the future. And this is not possible in the real world. So let's simulate this. We will use 3-page frames. As you can see, 1, 3, and 0 are added as 3-page faults. When we try to add the 3, we notice it is already present, so we count that as a hit and move to the next one. The 5 replaces the 1, as 1 is not needed in the future. The 6 replaces the 5, as 5 is also not needed in the future. And as we go to add the 3, we notice it is already present, so we count that as a hit. We had 7 pages and used 3 frames, whereas we had 2 hits and 5 faults, which is pretty good for an algorithm. Moving on to the last segment of this video, it is the About Us section. This is the About Us page of the website. On this page, we have information about us and the roles we undertook during this project. We are Group 3, Jeet, Neeha, Nandan, Srushti, Vruti, and Aakash. However, everyone contributed on all segments of the website. We hope you learned something new about page replacement algorithms, and thank you for watching the video.